This motion picture shows you how you can make materials for use in overhead projectors, opaque projectors, 3 1/4 by 4-inch slide projectors, and 2 by 2-inch slide projectors. A school's audiovisual room is our demonstration area. Here you will see how to make inexpensive projected materials designed to make teaching more effective. 3 basic properties characterize projected materials. First, transparency. A sheet of clean plastic or acetate is transparent. You can see through it. Second, opacity. A sheet of opaque material is absolutely light-proof. The material here is a piece of clear plastic coated with black carbon. Magazine pictures are opaque, too. And finally, translucency. Light passes through, but you cannot see detail through it. So much for the basic properties. Now let's see what you can do with them. With a grease pencil, you can make opaque marks on transparent acetate, which can be erased with a cloth or piece of tissue. Parts of a drawing can be prepared beforehand, allowing you to add to it in front of a class. The parts you want to protect are drawn on a second sheet, which is taped to the top sheet. This way, you erase only the parts you want to change. A valuable property of translucent frosted acetate is that you can write or draw on it with water-soluble pencils, black or in colors. Colored pencils on frosted acetate make an effective combination and are easy to use, too. You can buy a transparent acetate which has been prepared so that it will take watercolor or ink. Black India ink is opaque and makes clean, sharp lines on prepared acetate. A simple India ink tracing on prepared acetate makes a permanent teaching tool. Also, various types of lettering methods can be used to add captions. Prepared acetate is helpful for making simple 2 by 2 slides. But you're not restricted to India ink with prepared acetate. Colored inks can be used to differentiate between parts of a drawing or tracing. Or watercolors can be painted or sprayed on to add delicate shading effects, as in this larger display piece. As before, outlines and lettering are made with opaque India ink. Now let's look at what can be done with an opaque material, such as carbon film. It looks like carbon paper, but the base is actually a thin plastic. A scriber scratches away the carbon, leaving transparent lines. You will find it very easy to make clear diagrams on carbon film if you use a cardboard pattern or template. A template helps when you have to draw the same outline frequently. It may be an internal template or an external template, such as this state outline map. Now let's see how a teacher shows another use for carbon film.
I had a problem on my hands. How was I going to illustrate a business form to a large class? I decided to make a transparency for the overhead projector. I also decided to use carbon film, which serves very well for this purpose. I insert the carbon film in my typewriter with a couple of sheets of thin paper to protect it. Then I type, just as though I were typing an ordinary letter. When I'm finished, I discard the protective papers. It's the carbon film I'm interested in. Carbon film is rather flimsy and damages easily, so I fasten it to a thin cardboard mask which fits my overhead projector. Drafting tape works very well for this purpose. A piece of tape on each of the corners holds the film securely to the mask. All finished, and now to try it out. I use a 7 by 7 inch overhead projector in my classroom. And there is my letter. Now I will use a lettering guide and a mimeograph stylus to mark off sections of the letter. This is like writing with light. Instead of a metal stylus, I might have used a pencil. The purpose is to remove the carbon. This is what the class will see projected on the screen. It is a good solution to my problem of showing printed material to a large class. Of course, it is quite possible to write on the carbon film while the class is watching the projected image. I have found it an excellent way of getting and holding attention.
Here's a 3 1/4 by 4-inch slide on carbon film. If you would like a little color, add a piece of colored cellophane to the completed slide. Colored cellophane is suitable for some purposes, but a number of adhesive coloring materials, which may even be better, are now on the market. The adhesive color can be peeled from its wax paper support. Adhesive color will stick to any clean, smooth surface, so it can be used to color opaque pictures or transparencies. And you can get a wide range of colors as well as textures. By superimposing colors, various combinations can be made. Now let's see a teacher demonstrate how adhesive color can be used to make a simple projected slide.
I am making a 3 1/4 by 4-inch slide of a diagram I found in a workbook. I'm using a piece of prepared acetate because I can trace directly on it with India ink. I could leave the tracing as it is, but I think it will greatly improve the slide if I add some color and perhaps a texture background. This adhesive color is an easy material to work with. First, I cut a piece of textured background the same size as my 3 1/4 by 4-inch acetate tracing. I will cut the adhesive, but not the wax paper support. The secret is to cut lightly with a sharp knife or razor blade, pressing down just hard enough to cut through the adhesive. When I have outlined the shape with my knife, then I peel the adhesive from its backing. I use the point of the knife to separate the adhesive, and it peels right off. Now I lay the adhesive on the acetate and press down lightly to make it stick. If I made a mistake, I could always peel it off and start over again. The next step is to cut around the main part of the drawing, cutting just the adhesive and not the acetate beneath. Then I peel away the part of the adhesive which I don't want. Larger scraps can be saved for future use. Now that I have a textured background, I need a color to emphasize significant parts of the drawing. When I first cut a piece of color from its wax paper backing, I don't pay much attention to the size. It should be just a little larger than the area to be colored. Color adhesive separates easily from its backing. Another thing, the longer you leave it on, the harder it sticks. Right now I could peel this off easily, but a little later it would be much more difficult. Turning the knife lightly between the fingers makes it easy to cut smooth curves. And now I remove the trimmings, leaving behind a clean, sharply outlined color area. Of course, I could use additional colors, even overlap them, but I don't think they are needed for this slide. And that's all there is to it. In order to see how my slide will look on the screen, I use a temporary slide holder, just 2 pieces of glass hinged together with tape. And now the final test. How will it look? Quite satisfactory. Yes, colored adhesive is an easy way to add that professional touch.
This young woman is going to show you how to make your transparencies come alive as you present them to an audience. She's going to demonstrate the dot dusting technique using carbon film. She has just finished tracing a picture she has clipped out of a magazine. She strengthens some of the lines on her tracing and eliminates unnecessary details. But let her tell you the story.
Well, after I have a simple tissue paper tracing of the picture I want to use, I need a sheet of stencil paper or thin cardboard. Might as well make 2 while I'm at it. The next step is to tape the tissue paper tracing to the stencil paper. You'll see the reason for this in a moment. Using a sharp needle, I poke holes along the lines, holding the needle almost vertical to make nice round holes right through the stencil paper beneath. The greater the detail, the closer together the dots. I keep on until I have followed all of the lines on my tracing. Now you see why I tape the tissue to the stencil paper. So the stencil will last a long time, I strengthen the holes by brushing a little shellac over them. Sometimes I use lacquer for this purpose, or a liquid plastic, something that will dry quickly. Before I can go ahead with the next step, I have to dry the stencil. Usually it takes only a few moments. I will lacquer the other stencil after I finish this one. Now for a sheet of carbon film, carbon side up, with the perforated stencil on top. We call this the dot dusting method, so we need some dust. A chalkboard eraser is just the thing. Ordinary kitchen cleanser would do as well. A few gentle pats and rubs and we're done. And there it is, a dot-dusted carbon film ready for use. I use a 10-inch by 10-inch overhead projector when giving my demonstration so that I can face the group. I place the dot-dusted carbon film on the glass surface of the projector. The larger projector makes it easier to work on. Then, as I talk to the group, all I have to do is connect the little dots of chalk dust with a metal stylus. You can see the value of a simple, uncluttered drawing. And this is what the audience sees on the screen behind me, a living, meaningful diagram which develops with my lecture. As a way of capturing and holding the attention of an audience, I find that the dot dusting on carbon film method is excellent. It certainly helps my teaching.
When searching for classroom materials, many teachers turn to the beautiful pictures appearing in magazines. The problem is how to present such pictures to a class. Most magazine pictures are printed on clay-coated paper. Such opaque magazine pictures can be converted into transparencies for projection. What is a magazine picture? It's printer's ink on paper. Transfer the ink to clear plastic, take away the paper, and you would have a transparency. Once again, here's a teacher to show you how it is done.
When I have found a picture which I think I can use in my classes, I carefully remove it from the magazine. It is important to have clean working surface. I use plain newsprint paper for this. And to start off, I take a piece of transparent acetate plastic, which will fit my overhead projector. Next, some very fine sandpaper and a roll of cotton to make a pad. Steel wool works well, too. The idea is to sandpaper the surface of the plastic to make it look slightly frosted. After I finish one direction, I sandpaper at right angles to the previous strokes. Of course, if I had some frosted acetate, I wouldn't have to do this. There is a certain amount of dust which should be removed. I use the cotton which was in the sandpaper pad. This looks free of dust. And now for the next important step. I use good quality, genuine rubber cement and a fairly wide, soft-bristled brush. The rubber cement should be free of bubbles and thin enough so that it flows freely from the brush. Now I apply an even coating of rubber cement to the sandpapered surface of the acetate with quick, smooth strokes. Notice that I do not go over an area already covered with rubber cement. This looks like a smooth, even coating, so I put it aside to dry. Once again, a clean working surface. Next, I coat the surface of the magazine picture with rubber cement. Yes, right over the surface of the picture. And so on until the picture also has a smooth coating of rubber cement. I make sure there are no missed parts. This seems okay. And now I put the coated picture aside to dry. This takes about 6 minutes, more or less. The next step in this transferring process is to stick the acetate sheet and the magazine picture together, rubber cement to rubber cement. I rotate the acetate a quarter turn so that the brush strokes are at right angles to each other, and bow the acetate so it contacts the center first and smooth it down. This has to be right. There is no second chance. Now I have a sandwich of picture and acetate held together with rubber cement. At this point, I usually get rid of the excess rubber cement on the margin of the picture by rubbing it and brushing away the crumbs of rubber cement. And now comes an important step. There must be a very close contact between the magazine picture and the acetate. A smooth, hard object, such as the back of a comb, will do. The sheet of paper prevents scratching the picture. Now I rub at right angles to my previous strokes, so that I've rubbed every square inch of picture from top to bottom, both ways. Might as well tear off any unwanted printed matter, and the sandwich is ready for the next step. This involves soaking it in a pan of cold water. A few drops of liquid household detergent helps the water soften the paper. And now I let it soak for a while. The length of soaking time varies with the kind of paper, but it usually takes around 5 minutes. By now the paper should be quite soft. Yes, this one is ready. I begin to peel, and off the paper comes. There's a certain amount of clay or chalk still left on the printer's ink, to be washed off very gently. Now I've almost finished, and once more I lay the picture aside to dry. I find that I can greatly increase the transparency of the picture if I spray it with plastic. This also protects the rubber cement with the ink on it. You can see how plastic spray makes the picture more transparent. When I've finished spraying, I let the plastic dry completely. Any flaws? No, because I was careful in applying the rubber cement, and I did a good job in rubbing the acetate and magazine picture tightly together. A pair of cardboard masks will frame my transparency, and I can use the masks for short descriptive notes or to identify the picture in my filing system. And now comes the part I enjoy the most, the final test. How does it look on the screen? Yes, I've made a good transfer. Plenty of detail and good color. So, for the cost of a few minutes of my time and a few pennies worth of materials, I have a full color transparency, impossible to get so inexpensively any other way. Truly a valuable technique.
Yes, magazines not only provide pictures for transfer onto plastic, as we have just seen, but the same picture might have been cut out of the magazine and mounted on cardboard for use in the opaque projector. And the pictures don't have to be large. They might be a series of how-to-do-it illustrations taken from a magazine, which could be transferred onto plastic to make a set of 3 1/4 by 4 slides. You've just seen a number of techniques for making inexpensive materials for projection. And all of these techniques involve 3 basic properties: transparency as seen in clear acetate, translucency as shown by frosted acetate, and opacity as in opaque carbon film. Handmade projected materials can help you in presenting your ideas.